So up until now, given two vectors, we have the ability to work out the angle that exists in between the two vectors, and we can also project the vector b on top of a. That will then give us this vector here. We now need to develop a way of working out the area that exists in between two vectors. So given vector a, given vector b, we need to develop a way of working out this area here. And by the way, we can also work out the area of the parallelogram. So we can work out this area here, given two vectors. So now we need to develop a way of working out this area. Okay? So let's begin. So given two vectors, we have the ability to work out cos theta. We have the ability to work out cos theta. The area of this triangle is given by, hang on, draw a straight line down here. This would then be a right angle triangle. The area of this triangle, the area of this whole triangle here, is given by base, which is the magnitude of the vector a, times the height. Well, the hypotenuse here is the magnitude of b, times sine theta, because this is sine theta. So I hope you can see that the area here is given by this, where this is a magnitude, the length of a and the length of b. So it's quite straightforward. But here's the problem. When given two vectors, we have the ability to work out cos theta. We have the ability to work out cos theta. But here we need sine theta. The problem here is that we need a way of working. We know cos theta, but we don't know sine theta. So now we need a way of getting from cos theta to sine theta. If we can do that, then we can work out the area of this triangle. And by the way, we can work out the area of the parallelogram as well. So now we need to develop a way of getting from cos theta to sine theta. So let's develop that method. So given two vectors, we can rotate this 90 degrees. So this will be 90 degrees. So let me try and animate it. So my animation is very poor, so bear with me. Hang on. So let's try and animate the rotation. So let me animate it. So rotate it 90 degrees. So it will look something like this. Bear with me. It will look something like this. Okay, so it will look something like this. Okay, so it will look something like this. So the vector a, bear with me. So the vector a is from here to here. When you rotate it 90 degrees, so this here is a right angle triangle, a right angle now. So this is no longer a, is no longer vector a, but it's vector a prime. It's a new vector, but it will have the same magnitude as this one here, because vector will have a direction. The direction is from the origin to here. So you rotating it, this length here will have a new vector. It's a prime. Let's just call it a prime. So this is a right angle. This is a right angle here. This is a right angle here. This angle here is theta. So from here to here is 90 degrees. So this angle here will be 90 degrees, which is pi over 2. Take away theta. So this angle here will be pi over 2 take away theta. Let's just call this angle here theta prime. So this angle here is theta prime. Theta prime is 90 degrees. Take away whatever this angle was. Take away theta. So hang on. Let me just start again. So starting with this vector, rotate it. Starting with this whole thing here, rotate it 90 degrees. So rotating this 90 degrees. So this thing here will be a right angle here. This angle here will be theta. This angle here will be theta prime, and theta prime is pi over 2 take away theta. Okay, so that will then take us to here. I will continue in the next video. Okay.